Okay guys, let's talk about how to take the derivative of an exponential function. So if we have y equals e to the x and we want to take the derivative of our function, again from the graph a minute ago, we know that the derivative of e to the x is e to the x. Oftentimes you'll hear me say, write what you see when it comes to an exponential function. But let's talk about y. Let's assume our function is an exponential, but rather than just having e to the x, let's say the function is e to g of x, all right? So we have another function up here. All right, well then the derivative is going to be chain rule. All right, so what does that mean? That means we are going to, again, as you'll hear me say, write what you see. So in the derivative, we will write what we see times, what does chain rule say? Times the derivative of the inside function. So times the derivative of that exponent, or the derivative of g to the x. All right, so let's go back over here now. Y is the derivative of e to the x, e to the x. Well, if we go by what we saw over here, then the derivative of y is going to be, well, we write what we see, e to the x, times the derivative of x. And what's the derivative of x? Well, that's just 1. And that is how we get the derivative of e to the x is in fact e to the x. Let's go through a few examples now. Okay, here's a few examples. Let's consider taking these derivatives. So remember what I was just saying with chain rule. First we're going to write what we see, and then we're going to take the derivative of the exponent. So the derivative of this function, e raised to negative 3x squared. In the derivative, we are going to write what we see. And then we're going to multiply this, and I'll do this in another color. We're going to multiply this by the derivative of negative 3x squared, which is negative 6x. So our derivative is negative 6x e to the negative 3x squared. It's not necessary to write the negative 6x first. I just do because that's just typically how we make sure we see that negative. That's just typically how we write exponentials. Okay, let's move on. Let's go over here to 6e raised to the x cubed. Well, you guys are going to catch on to me saying this. We're going to write what we see, which is everything. Okay, again, notice how we do not change what's written in the exponent. I'm writing x cubed, okay, times the derivative of x cubed, which is 3x squared. So when we clean this up, I'm going to multiply my 6 and my 3 to get 18 x squared e raised to the x cubed. Okay. All right, let's do this last one. All right, in the derivative, we, guess what, write what we see, which is e to the negative x, times the derivative of negative x, which is just negative 1. So our derivative is just negative e to the negative x. Okay, let's do a few more complicated ones. Let's look at this function. All right, if we read it to ourselves, we have f of x equals x times e to the x. So again, notice as I teach you guys, let the English drive what you're going to do. So we have x times e to the x. So we know that here we're going to have product rule. If I can write the word product. Okay, so what is product rule? Product rule says take the derivative of the first function, so the derivative of x is 1, times e to the x, plus the first function times the derivative of the second function. Then the derivative of e to the x is just e to the x. All right, so we can clean this up, and we get e to the x plus x e to the x. And that's our final answer. Okay, let's take a look at this example. We've got f of x equals e to the 4x squared divided by x squared. All right, again, what did we read? We read divided by x squared. So what does this mean? This means we're going to have to use quotient rule when we want to take this derivative. Okay, so in the derivative, what does quotient rule say? Quotient rule says low d high. All right, so I want to take the derivative of the numerator now. So I'm going to write what I see. Okay, and now I'm going to multiply that by the derivative of that exponent. So the derivative of 4x squared is 8x. Okay, minus high d low. So now I need to multiply this by the derivative of the denominator, and the derivative of x squared is 2x, all divided by the denominator squared. All right, so we've got a little bit to clean up here. All right, so we have x squared e to the 4x squared and an 8x. So I can write that as 8x to what power? When we're multiplying x's, we're going to add the exponents. All right, and I keep my e to the 4x squared minus 2x e to the 4x squared, all divided by x to the 4th. All right, again, how did I get x to the 4th? You guys note I did not add them, even though 2 plus 2 is 4. When we raise a power here to a power, we are multiplying, and 2 times 2 is 4. Okay, let's do one more example, just slowly increasing the level of difficulty here. So now we see we kind of have what looks like a quadratic, 3x squared minus 2x plus 4, except that every single term is multiplied by e to the x. All right, so 3x squared e to the x. If we want to take this derivative, what rule are we going to have to use? And the answer is product rule. We have 3x squared times e to the x. All right, here we have 2x e to the x. What rule are we going to have to use? Again, we're going to have to use product rule. All right, and here where we have 4 e to the x, we do not need product rule because we don't have another x term. We only have this 4, which serves as a coefficient. Okay, so let's take the derivative piece by piece. Okay, I will use different colors so you guys can try to follow me here in what I'm doing. I will start with blue. All right, so with this first term, I'm going to use product rule. Okay, and everywhere I don't take a derivative, I will certainly stick with the black color. All right, so we have the derivative of the first function. The first function is 3x squared. So my derivative is 6x times the second function, which is just x squared, plus 3x squared, that's the first function, times the derivative of e to the x, which we know now is just e to the x, minus the derivative of 2x, which is 2, times the second function. All right. I would say plus the first function, but that first function is, oopsie, let's go back, minus 2x times the derivative of the second function, which is e to the x, so that's just, again, e to the x, plus the derivative of 4e to the x, which is just 4e to the x. Okay, so we clean this up, and we get 6x e to the x plus 3x squared e to the x minus 2e to the x minus 2x e to the x plus 4 e to the x. So we obviously have a few like terms. Okay, so we do have a few like terms. Obviously this is a like term. The 6x e to the x is a like term with minus 2x e to the x, and the minus 2e to the x is a like term with the 4e to the x. So when we clean this up, our final line here, and I'll just write it in descending order, is 3x squared e to the x. Then we have 6x e to the x minus 2x e to the x, so we get plus 4x e to the x. And then we have minus 2 and plus 4, which gives us plus 2 e to the x. And this is our final answer. Let's go back for a second to the example we were just working on. What's something else we could do rather than kind of attacking each term? So we had to use product rule twice. What else could we do? Well, one thing, we can rewrite our function by factoring out the e to the x. If I factor out the e to the x, then I can clearly see I have the exponential function times this quadratic. And then if I want to take the derivative, note I only need to use product rule once. Okay, so again, I'll stick here with the derivative being in red. So we have the derivative of the first function. Well, the derivative of e to the x is e to the x times the second function, which I'm calling the quadratic, plus the first function times the derivative of the second function. Now the derivative of this quadratic, you guys are getting good at these now, is going to be 6x minus 2. Lastly, we can clean this up. Okay, two ways to do it. I can distribute this e to the x, and I'll do that. And while I do that, I'm also going to combine like terms, and I'll try to show you guys what I'm doing here. So first I distribute the e to the x to the 3x squared, so I get 3x squared e to the x. Okay, note now, let me change my color here. If I distribute the e to the x to the minus 2x and distribute the e to the x to this 6x, I'm getting minus 2x e to the x plus a 6x e to the x. I'm just doing this in one step, which is going to give me plus 4 e to the x. Certainly we can distribute the e to the x and then combine everything in two separate steps if we want. And then lastly, let me grab one more color here. If I distribute the e to the x to the 4 and I distribute the e to the x to the minus 2, net this is giving me plus 2 e to the x. And actually I just noticed here I forgot an x. And here, this is our final answer, and if we compare this back to the example a minute ago, working it out twice with product rule, we have the exact same answer.